Today we're looking at section 4-1, graphing relationships. Again, remember, take out something to take notes on. You may use your notes on quizzes. Also pause the video at any time to write your notes down or go back if you've missed some information, and complete the check it out problems after each of the examples. We have two learning targets today. The first one, I can match simple graphs with situations. And the second, I can graph a relationship. If you forgot how to graph, go back and look at section 1-8. So again, section 1-8 is Introduction to Functions, and we're going to be moving into functions in this unit. So that might be a good unit to go back and review. Some vocabulary words. First one is a continuous graph, and that's a graph there all the lines or the dots are all connected, so we make a line or curves. And a discrete graph is with only distinct points. It's going to be a line where there are only points that could be going up or down, but you do not connect the dots. So something with counting would be discrete. Continuous would be a measurement. And graphs can be used to illustrate many different situations. You've seen a lot of graphs in your time, do quite a few in your science classes. Graphs are also great to show trends, like on a cardiograph, a doctor can see a patient's heart rate's functioning. And we can always write a graph to a given situation looking for key words in the description given. So we'll do all this in the lesson today. Our first example is to use the keywords and match up which graph represents it best. Each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves. Eventually, there are no more leaves on the tree. So looking at some of the keywords, we have several leaves fall from a tree. That's not a whole lot. So graph A, we're getting more leaves, so we can get rid of graph A from the beginning. Okay, B and C, we're still they're both declining. This is a little sharp in C here, but we'll see. One day, a gust of wind blows off many leaves. And eventually, there are no more leaves on the tree. So thinking about which it's going to be, again, notice leaves, number of leaves are on our y-axis or dependent, and the time, which is our control variable, is on the x-axis. So looking at this, again, I'm leaning towards B. One day, gust of wind blows, so we drop a whole bunch down, and eventually we go to nothing. So let's go with B. With C, we have some point in time there are no leaves falling. It's a horizontal line, so no leaves came off the tree. So the correct answer here is going to be B. Here is one for you to check it out. And again, match the correct graph. Look for key words, descriptive words in that. And again, we talked this at the beginning, continuous graphs and discrete graphs. So looking at the theme park attendance here, this graph here, we are counting people. People is on our y-axis, years is on our x-axis, and we're counting. So this is going to be a discrete graph. And we're not going to connect the points because people have to be whole people. So whole numbers, you're counting something. It's going to be discrete. So now we want to sketch a graph for the situation that we're given and tell whether the function or the graph is continuous or discrete. So a truck driver enters a street, drives at a constant speed, stops at a light, and then continues. And again, notice our y-axis is a horizontal or the vertical axis, and our x is the horizontal axis. Okay, so to graph this, looking at this, the driver enters the street. So along here, his speed is going to be going up. And again, speed is going to be on our y-axis. So over time, he's going faster. Then he goes at a constant speed. So that's going to be a horizontal line along here. He gets to a stoplight, so he's got to slow down, bring his speed down to nothing or down to 0. Then he has to go back up again, and he goes at a constant rate also when he's all done with that. So in this case, this graph is going to be continuous. The lines or dots are all connected to form a line or multiple lines there. So look at this one now. We want to sketch a graph for the situation. Again, is it continuous or discrete? a small bookstore sold between 5 and 8 books each day for 7 days. So on this graph, notice again, it's very important where our axes are labeled. Books sold is our dependent. Number of books sold is dependent upon number of days. And the title on the graph is book sales. So very important in how you label your axes. Okay, so to graph, we can plot the points. The range has between 5 and 8 books. That's what we're told. So it means you can sell 5 books, 6, 7, or 8 books during those 7 days you're selling. So in this case, this is going to be a discrete graph. We cannot have partial books, and so we do not connect the dots. So again, counting is discrete. And now it's your turn. You've got 2 check it out problems. Now let's look at these graphs here. Both graphs show a relationship between a child going down a slide. The graph on the left, graph A, represents the child's distance from the ground related to time. So over time, the child gets closer to the ground. Graph B situation represents the child's speed over time. So he starts out slow, hits a part, picks up some speed, and then he slows back down before he gets off the graph. So it's really important to figure out again how your axes are labeled, because these graphs look very different, but they both show a child going down a slide. So now we're going to write a relationship or a possible situation for the given graph. Okay, so on this graph, again, notice how our axes are labeled. We have time on the x-axis, time controlling the speed. So speed, in this case, the red line here shows the speed's decreasing over time, and then the speed remains constant, and then the speed goes down to nothing over time. So a possible situation could be a car approaching traffic. So he's approaching traffic, so he's slowing down, the car is slowing down, drives at a constant rate because he's sitting in traffic, and then eventually comes to a dead stop. Rush hour, that happens. Now it's your turn to write a possible situation for the given graph. This graph here is a discrete graph. The dots are not connected, so keep that in mind when you're coming up with your possible situation. Also, pay attention to how your axes are labeled. We have students and pizzas bought. Pizzas are dependent on the number of students. So to summarize this lesson, when you have a vertical line, it's going to have a constant x value. That vertical line is going up and down. A horizontal line has a constant y value. It's like the lines here on the paper. That's horizontal, and this line here is going to be vertical. Graphs are read from left to right. The control variable goes on the x-axis, and the dependent variable goes on the y-axis. And you need to understand what your x and y axes represent. How are they labeled? Again, think of the child going down the slide example, or in this case, a person who runs uphill at a constant speed. That's a speed versus time graph will be horizontal, or a distance or height versus time graph will slant upward. Same situation, but a different way to represent the information given. Bring any questions you have to class, and thank you very much.